Let's look at inverse variation. Inverse variation, this is the opposite of direct variation. In this type, increase in one quantity leads to decrease in the other and vice versa. It is represented as P varies inversely as Q, or when we introduce our constant of proportionality, which is K, and then we introduce our equality sign, this relation is represented as P equals to K over Q, where K is the constant of variation. Let's take explanation on inverse variation. If a laborer can clear a piece of land in 6 hours, how long will it take either 2 men or 5 men to clear the land at the same rate? If a piece of land is cleared by one laborer, depending on how big the piece of land is, if one laborer is working on this piece of land, it will take a longer time for this one laborer to finish clearing the land or finish working on the land. But if more laborers are employed, it will take lesser amount of time for the work to be finished. So from the above statements, you will realize that the greater the number of people, the less time it takes to clear the land. Similarly, the greater the speed of a car, the less time it takes to cover any given distance. So these two are examples of inverse variations, and from our definition, we say inverse variation is increase in one quantity leads to decrease in the other. So here, increase in number of laborers leads to decrease in the amount of time required to get the work done, and increase in the speed relates or amounts to decrease in the amount of time it takes to cover a given distance. So we see that this kind of variational relationship is one that when one quantity increases, the other decreases, and when one decreases, the other increases. Okay, so these two are examples referring to the case of the laborer and the speed of the car. These two are examples of inverse variations. In the first example, where we looked at the laborer, in the first example, the time for a piece of work is inversely proportional to the number of laborers employed. The time taken to cover a journey is inversely proportional to the speed. These relationships can be written as T varies inversely as M, where the time taken to complete a given work, or the time taken to complete a piece of work varies inversely as the number of employees or the number of laborers who are hired to do the work. So if we introduce our equality sign and introduce our constant of proportionality, T will be equal to K 1 over M, and K times 1 is K, that will give us K over M. And same thing here, T is equals to K 1 over S, and T is equals to K times 1 is equals to K over S. So this is the way we represent inverse variation in equation form. And then we solve for the value of K, and once we get the value of K, we can know the formula connecting the two variables or quantities. So once we get to know the value of K, we would be able to know how T is connected to M, or the relationship between T and M, and also when we get to know the value of K by solving for it, we will know the relationship between T and S. Number 1, if Y is inversely proportional to X and X is equal to 3 when Y is 4, find Y when X is equal to 2. So for inverse proportion or inverse variation, Y is inversely proportional to X. So let's introduce our constant. Y is equal to K over X, equation 1. So from equation 1, I'm going to make k the subject of the formula. From 1, make k the subject of the formula. Subject of the formula. So k equals to x, y. So if k is x, y, then we bring the values given for each of the letters. When x is 3, that's the first values given for each of the letters. When x is 3 and y is equals to, when x is 3 and y is equals to 4, k is equals to 3 times 4, which is equals to 12. So if you put, so from 1, that is substitute the value of k into k in equation 1. So into equation 1 we're going to have, which is from 1, y is equals to 12 over x. So this is the relationship between y and x. So this is between y and x. Then we say when x is 2, y is equals to 12 over 2. 2 here 1, 2 here 6. Therefore y is equals to 6. So that's the value of y when x is 2. Number 2. Y varies as x squared. Y varies as x squared. And if y is 3 when x is 4, find y when x is 4. For number 2, y varies inversely as x squared. So let's correct that. So y varies inversely as x squared. So let's get a formula that will connect the two quantities y and x squared. So y, introduce the equality sign and then our constant k over x squared. So equation 1. So from 1, make k the subject of the formula. K equals to x squared y. Now when x is equals to 4 and y is equals to 3, what is k? K is equals to 4 raised to the power of 2 times 3. Okay, so times 3. So 4 raised to the power of 2 is 16 times 3, that's equals to 48. So k is 48. The formula connecting x squared and y, connecting y and x squared from equation 1, that is from equation 1 is equals to y. Now in place of k, put the value 48 over x squared. Now question went on to tell us that the question wants us to find the value of y when x is 4. So when x is 4, from this relation, y is equals to 48 over 4 raised to the power of 2, which is equals to 48 over, else is 16, or let me just put 4 times 4, which is equals to 16. 4 here 1 into 48, 12. 4 here 1 into 12, 3. So y is equals to 3. Therefore y is equals to 3. T varies inversely as the square root of f. T varies inversely as the square root of f. So t is equals to k over square root of f, equation 1. So from 1, k is equals to t root f. So when t is equals to, when t is 7 and f is equals to 2 over 1 over 4, k is equals to 7 times square root of 2 over 1 over 4, which is 7 times square root of 4 times 2, 8 plus 1, 9 over 4. 9 over 4. So 7 times square root of 9 is 3. Square root of 4 is 2. 3 over 2. 7 times 3 is 21 over 2. So 21 over 2 is 2 into 10, that's 10 over 1 over 2. So k is equals to 21 over 2. You can leave it like this or leave it in this form, but because we're going to substitute it into equation 1, I prefer we leave it this way. So from 1 to get the formula connecting t and root f, I'm going to say t is equals to, in place of k, we put our value 21 over 2. 21 over, so the numerator is 21, the denominator is 2, so to 2 root f. This is the formula connecting t, and this is not second root of f, this is 2 root f. So that's the formula connecting t and root f. Then it says find t when f is 2 over 7 over 9. Find t. So when f is equal to 2 over 7 over 9, t from this formula is equals to 21 over 2 root 2 over 7 over 9, which is 21. 2 times 9 times 6 is 18. 18 plus 7 is 25. Square root of 25 over 9. And this will give us 21 over 2 times square root of 25 is 5. Square root of 9 is 3. And 2 times 5 is 10. This will give us 21 over 2 times 5 10. 10 over 3. This will give us 21 divided by 10 over 3. 21 times 3 over 10. So 3 times 21 is 63 over 10. And 63 over 10 is equals to 6 over 3 over 10. That's the value of t when f is 2 over 7 over 9. If x and y are variables and k is a constant, which of the following describe an inverse relationship between x and y? So we're given these options to, so once we're able to describe the inverse relationship between x and y, we have to see which of these options match the right relationship. So x, okay. Now what we see here is that y is the subject of the formula, so which means y is inverse proportional to 1 over x. So let's introduce our constant proportionality. Y is equals to k over x. So that's all. So let's check which of them matches what we have on the board. Y is equals to k over x, option B. So our answer is B. That's the correct answer. The weight W of a body varies inversely as the square of its distance d from the center of the earth. So weight varies inversely as the square of the distance from the center of the earth. So weight is equals to k d squared. Let's call this equation 1. So the body weighs 80 newtons on the Earth's surface. So let's get our K. So from 1, when we make K the subject of the formula, this will be our equation. Q is equals to W D squared. So when weight is equal to 80 newtons and distance and D, which is the radius of the Earth, and D, if the radius of the Earth is 6,400 kilometers, 6,400 kilometers, then K is equals to 80 times 6,400 raised to the power of 2. So 80 times 6,400 times 40,096,000 times 80, 327 is equal to 3.27. I'm going to express it in standard form. 3.2768 times 10 raised to the power of 9. That's the value of K. So that means let's get the formula connecting D squared and W. Therefore, from equation 1, the formula connecting, which is another figure 1, the formula or the expression, connecting the weight of a body, connecting the weight of a body, connecting the weight of a body and its distance from the center of the Earth, and its distance D from the center of the Earth is. So W is equal to K, which is 3.2768 times 10 raised to the power of 9 over D squared. So this is a formula, and we call this formula figure I. Then I says calculate the distance of a body of 20 newtons from the center of the Earth. So we are going to go for the distance of a body of 20 newtons from the center of the Earth. So write out the formula again. W is equals to 3.2768 times 10 raised to the power of 9 over D squared, where W is equals to 80, 20 newtons, where W is equal to 20 newtons. So to get D squared, we make D squared a solid formula. So D squared is equals to 3.2768 times 10 raised to the power of 9 over W. So D is equal to the square root of 3.2768 times 10 raised to the power of 9 over W. Now we're told that W is 20 newtons. That's the value given to W. So D is equals to square root 3.2768 times 10 raised to the power of 9 over 20. So this will give us 16 163.84.000. Now look for the square root of this value. 12,800 kilometers is the distance. Now figure 3 says, calculate the weight of a body which is 1,600 kilometers above the surface of the earth. So basically going to make use of that formula, W equals to 3.2768 times 10 raised to the power of 9 over d squared. Now in this question number 3, we have to look for the weight of a body which is 1,600 kilometers above the surface of the earth. That's the distance from the surface of the earth. So W, so where D is equals to 1,600 kilometers, and W is equals to 3.2768 times 10 raised to the power of 9 over 1,600 raised to the power of 2. This is equal to 3.2768 times 10 raised to the power of 9 over 256. So I'm going to convert the standard form. 2.56 times 10 raised to the power of 10 to the power of 6. So you can equate this to 3.2768 times 10 raised to 9 times 10 raised to minus 6 over 2.56. So this is equal to 3.2768 divided by 2.56. 1.28 times 10. 9 raised to 9, since the bases multiplied by each other, that's we're going to add. So 9 plus minus 6 will give us 3. So let's convert this back. So 1.28 times 10 to the power of 3 Newton, or if you say 1,280 Newtons. That's the answer. Is the answer. Figure 3. If y plus 2 varies inversely as x, okay, so y plus 2 is equal to k over x, equation 1. So from 1 k is equals to x y plus 2. So when y is 3, and x is 2, k is equals to 2, 3 plus 2, 2, 5, 10. So from 1, which is here, y plus 2 equals to y plus 2 is equals to 10 over x. That's the formula connecting y plus 2 and x together. So find y when x is 5. So when x is 5, y plus 2 is equals to 10 over 5. 5 here 1, 5 here 2. So y plus 2 is equals to 2. So come over here. So y plus 2 is equals to 2. Y is equals to 2 minus 2. And y is equals to 0. Number 2. N varies inversely at the square root of n. Square root of n. So we say n is equals to k square root of n. Equation 1. So from 1, k is equals to n root n. So if n is 5 when n is 9, okay, if n is 5, so when n is equals to 5 and n is equals to 9, k equals to 5 square root of 9, which is 5. Square root of 9 is 3, I can 3 is equals to 15. So from 1, n is equals to 15 over square root of n. So this is the formula connecting n and n. So state the relationship between n and n. Therefore, the relationship between n and n is n is equals to 15 over square root of n. Y varies inversely as the cube root of x. Yes, as the cube root of x. So 1 over third root of x. So y is equals to k third root of x. Okay, so cause equation 1. So if from 1, make k the subject of the formula. So k is third root of x y. So when x is equal to 0.125 and y is equals to 4, k is equals to third root of 0.125 times 4. You can express this as third root 125 over 1000 times 4. The third root of 125 is 5. The third root of 1000 is 10 times 4. 5 here 1 into 10 is 2. 2 here 1 into 4 is 2. So k is 2. So we say from 1, which is this equation, we want to get the formula connecting y and the cube root of x. Y is equals to k is 2. And it was 2 over third root of x. This is the formula connecting y and cube root of x. Then when x equals to 8, y is equals to 2 over the third root of 8. So 2 equals to 2. Third root of 8 is equals to 2. Now the third root of 8 is equals to 8 1 over 3. This will give us 2 raised to the power of 3, 1 over 3. 3 times 1 times 2, 3 raised to the power of 3, 3 over 1, 3 over 1. So 1 divided by 1 is equals to 2 raised to the power of 1, which is equals to 2. 2 here, 1, 2 here, 1. 1 divided by 1 is 1. Therefore, y is equals to 1.